coronavirus has happened in the past, be it the SARS outbreak in 2002 or the MERS outbreak in 2012. How is this pandemic different from the previous outbreaks?
There are a couple of things which make this virus unique. One is our behavior. Compared to 20 years ago, our planet has become smaller in terms of people reaching one place to other. So when we travel, we also carry things like infection. The second thing is this virus is far more infectious than earlier SARS or MERS is tenfold or even more infectious than those. And that's what has given this virus advantages. Luckily, it's not as lethal as SARS and MERS because they were much more dangerous. So if this kind of infection happened that time, that would have wiped out a huge number. So this is less dangerous in terms of mortality, but is extremely infectious. Probably, more infectious than these are than only the measles and or something like common cold of a similar category. Otherwise, so that's what has led to the what we have observed as a pandemic because it spread so fast. You have seen in November sometime we found that there's a variant called Omicron in African countries, and within 4 or 5 weeks we have shared the air and everybody all world there was Omicron. So that fast is the spread of this virus. So that has given this advantage.
So the spread, Dr. Mishra, how were the earlier outbreaks curtailed, and why are we still really struggling to put an end to the COVID-19 pandemic? This is also when we have so many vaccines, and the vaccines have been developed in record time. So this was not the case earlier. So do you think it's because, again, the way it's spreading because of the infectiousness of the disease?
Exactly. Yeah. So when a virus becomes infectious, it has many advantages because this is able to present newer and newer variants faster, because variants will come only when the virus infects another individual and creates new mutations. Most of them will be not useful for the virus, so they disappear, but few that are more infectious, they survive and they start to dominate in the population.
Sure.
And since this is being infectious, one infected person can infect 10 other infected people, while MERS and SARS will infect maybe 1 or 2. So that means that you can imagine there's a chain reaction. Yeah. So earlier ones were not so infectious. Once people realized, very little care just terminated the chain, and one of them is disappeared and other one once in a while keep coming. Yeah. But this one, because of its infectiousness, is spread fast, and newer variants also express themselves, or they spread far more with larger speed.
Okay.
As you mentioned, we have vaccine now, so we should be able to control that, and that's what actually has happened. The vaccines have saved millions of lives. So what is happening is that vaccines are not able to prevent the infection. They are able to prevent the seriousness of the disease. So people may get infected, but our immunity defense and virus is not able to cause much damage. Although to some degree it will prevent the infection in the beginning of the infection as well. But since the virus spreads fast, more variants come, then before our body gets prepared, the new variants starts to attack. And that's why like Omicron spread so fast. Although most people had prior immunity of one kind or other, but this was able to break through that immunity and spread. But luckily, as I said, because of the prior protection, those who were either infected or were vaccinated did not suffer much from Omicron, but others did suffer a lot. Many countries, lots of deaths because of Omicron, where there were no vaccination or less infection prior to.
So vaccination definitely, I think, is key.
Absolutely.
And of course, like all COVID protocols are still important, from wearing a mask to maintaining social distancing. Moving on, Dr. Mishra, something which we want to know about is, just for our viewers, a very, very basic question. What is genome sequencing and what role does it play in disease outbreaks or its prevention?
So genome is the genetic material of all living beings. Like we are unique, or what we are because of our genome. So this virus genome is in form of RNA. Most of the other organisms have DNA as their genetic material. And the complete sequencing, that means reading the complete detail of this genome, is called genome sequencing, because that's essentially the chemical units that make the genome we decipher by using some technology and machines. So we know exactly what those 30,000 letters in this virus are. So now, since the virus is changing, a change virus then infects, and then new chains are added and so on. So we can actually plot the relationship between one infection to other, the way we can plot the relationship among individuals, parents and their children and their grandparents and so on, by just reading their DNA sequence. Similarly, by reading the genome of the virus, we can actually connect the relatedness of this virus, same virus with different variants, and find out how it is spreading, which are the paths, whether it went first to Bombay, then to Delhi, then to Kolkata, so on. So we can actually figure out if we do in detailed way. Second thing is, as the virus is changing, new and new variations are coming, and some of them will be more harmful, some of them may be less harmful. So suddenly, if we see people are falling sick more than previous, so or suddenly there is more infection than earlier, so we wonder whether a new variant has come, or people have done partying and marriage dinner, and that is why it has spread. So if you go and sequence, you will immediately know. For example, now we know the recent increase in cases is not because of new variant. It is because of the activity of the people. But when we see that cases are increased and we see this new variant, then we know we have to take additional precaution. New bug has come around. And the third thing which genome sequencing does is the finding the target of the virus, which can be used for the drug and of course the vaccine. Why vaccine came so fast? Because the moment the virus infection was identified, its sequence was made available, and within weeks, people started working on the vaccine. And there was some prior lead because of the vaccination that was tried with the earlier SARS virus. So same thing was adopted, and the vaccines did become available extremely fast. It was like magic. None of us were expecting so many vaccines will become available, and they have been really helpful in fighting this
disease. Yes. Again, in terms of genome sequencing, how big are India's capabilities compared to other countries in the world, and what kind of infrastructure does India have for genome sequencing?
So genome sequence capability is reasonable in our country, particularly for sequencing the genome of the SARS-CoV-2. Is actually trivial in terms of, if you think of the technology and capacity that we have. We have tremendous capacity for this. Of course, there are countries like UK and all, they are far ahead of us, even they are smaller countries in terms of genome capacity. But sequencing the SARS-CoV-2 genome is not really, capacity is not an issue. We have a lot of that. There are many places, 10, 12 places where you can do very, very high throughput. You can sequence thousands and thousands in each day. But there are hundreds of other centers where you can do small scale sequencing, which is reasonable and what is actually desired in that detail. So we have capacity. Only thing we do not have is that we need to import the chemicals, the consumables that are used to run those machines. We have machines. Once you buy the machine, then it is there. But the consumables that are used, they are imported, and that costs money. And sometimes if you could make our own, that will become cheaper. So for example, these days, each sequencing will cost a few thousand, maybe 3,000-4,000. Depending upon which machine you are using, what is the throughput you are using, it may cost a couple of thousand, or it may cost 5,000-6,000. But if we could make our own reagent, it may go down maybe even tenfold.
The cost,